Hello guys, and welcome back to my channel. So if you're new to this channel, please subscribe and click the notification bell below. So today we are going to talk about logistic regression as a neural network. So the last time we talked about sigmoids, right? And then I showed you how sigmoids relate to as a SIM unit of a neural network, right? But the problem arises because we're using a linear sigmoid model, right? So if you still remember, we're using it was z is equals to w x plus b, where w were the weights and then x were the features, and then this is the bias, right? If you still remember. So what happens is with a linear model, if we change the weights, this causes the output to change, this causes the output to increase so much. So we don't want the output to increase that much if we change the weight. So to do that, we are going to use the logistic regression model as an example of a neural network, because the logistic regression is in so many ways similar to a neural network. So the logistic regression is used for binary classification problems. So what are binary classification problems? So let's take, for example, we want to classify, given the blood pressure and then the sugar levels and then the diameter of the arteries. We want to determine if a person has a heart disease or not. So we are going to assign 1 if a person has a heart disease and 0 if a person doesn't have a heart disease. So that's an example of a binary classification problem, and the logistic regression is used for such tasks. So what we want is given x. So what we want is given x we want to the output y hat, which is equal to the probability of y is equal to 1. So this is going to be the probability of someone having a heart disease given x. So x, which are the input features, which are like the history of diabetes, the blood pressure, and the arteries diameter, right? So what the logistic regression does is that we, instead of using this algorithm y is equals to wx plus b, we are going to use y is equals to the sigmoid multiplied by wx plus b. So what is this sigmoid? So the sigmoid is equal to 1 over 1 plus e to the power of negative x. So this is the sigmoid function. That's what we call the sigmoid function. So what the sigmoid function does is that if the values are greater than 0.5, it will classify y as 1. If it's less than 0.5, it will classify y as 0. So let's see the sigmoid function. So this is the sigmoid function. Here we have y, and then here we have x. So I'm sorry about that. So on the y-axis we have y, and then on the x-axis we have x. We have values of x. So the sigmoid function is like this. Sorry about this curve. Should be something like this. It should be something like the sigmoid function should be set something like this. So this is the rough diagram of the sigmoid function. Here we have a sigmoid of x, and then here we have x, and then here is 0.5, and then we have the maximum, which is 1, and then we have the minimum, which is 0 here. So what the sigmoid does is, if x is very large, so as you can see we have positive x and negative x. So if x is a large number, so if x is a large number, then y is equals to 1. Y is equals to 1 when x is a large number. So when x is a large number, and here y is going to be 0, as you can see here. Y is equals to 0 when x is a small number. So this is the sketch diagram of the sigmoid function. So this sigmoid function is what allows us to classify if is what allows us to classify if a person has a disease or if the person doesn't have a disease. So the sigmoid function, as you can see, this sigmoid function is used in some neural networks. It's going to be used in some neural networks if we have problems where we need to classify if someone is positive for something and it's negative for something. So thanks for watching, guys. So in the next video I'm going to talk about the cost function for the logistic regression, which is going to lead us to a very important concept, which is the gradient descent, which is a very important topic in neural networks and deep learning. So thanks for watching, guys. Please click on the subscribe button and the notification bell on.